Imagine for a second that everything you believe about Tesla's lead in the electric vehicle world is actually an illusion created by clever marketing and a decade-old head start. Because while the world was busy watching Elon Musk's rockets and Starlink satellites, a silent titan in China was busy rewriting the very laws of automotive physics in a way that makes the current Model S look like a relic from the Industrial Revolution. We aren't just talking about a new car brand or a fancy touchscreen, but a total structural and chemical apocalypse for the legacy auto industry that has been developing behind closed doors for years. If you think charging for 20 minutes is fast, or that a 700-kilometer range is impressive, then you are living in the past, because what is being revealed today is a platform so advanced it doesn't just drive, it thinks, it doesn't just carry passengers, it protects them with aerospace-grade integrity. Stay tuned for the next few minutes because the hierarchy of the car world is about to be demolished, and the name at the top is one you never expected to see coming. The history of the global technology race is rarely defined by the most visible players who dominate the headlines, but rather by the silent innovators who operate in the shadows of the laboratory, away from the glare of the press conferences and the hype of social media cycles. While Tesla was demonstrating its prowess in artificial intelligence and autonomous software, and while Toyota was doubling down on its traditional engineering heritage to protect its hybrid kingdom, and while BYD was rapidly constructing a massive vertical empire of battery production, a Chinese company was quietly cultivating a revolution that went largely unnoticed by the Western media. This company, known as Chery, was not merely trying to build a better car, but was instead focused on developing a foundational platform that could fundamentally shift the entire trajectory of the electric market for the next 50 years. When most people think of high-end electric vehicle technology, their minds immediately jump to Palo Alto and the sleek minimalist designs of Tesla, but the real story of the future is far more complex and strategically deep than it appears on the surface. Behind the scenes, Chery has been engineering the E0X platform, which is not just a frame for a vehicle, but a comprehensive ecosystem that transforms our entire understanding of how a car should be conceived and manufactured, from the first line of code to the final pour of molten metal. The critical question we must ask is whether Tesla is truly the permanent leader of this race, or if they are simply a pioneer who is about to be overtaken by a player poised to make an even more significant technological leap. If the preparations being made by Chery are successful, the next major shock to the global EV market will not come from a software update or a new marketing campaign, but from a total transformation of the vehicle's physical and digital soul. To understand why this is such a massive shift, we have to look at the current state of the industry, where most legacy automotive brands are still trapped in a historical prison of their own making. Despite the shiny exteriors and the futuristic LED lighting, most electric cars on the road today are still being developed using a philosophy that was originally perfected for internal combustion engines fueled by petrol and diesel. In many cases, these manufacturers are simply taking an old-world chassis and trying to force-fit electric components into a space that was never meant for them. This approach leads to what engineers call automotive Tetris, where parts are shaved down and cables are rerouted just to make the battery fit into a frame that still retains the unnecessary tunnels and mounting points required for a transmission or an exhaust system. This legacy design philosophy results in vehicles that are unnecessarily heavy and structurally compromised because they are built from dozens of separate steel parts that must be welded or bolted together in a tedious and error-prone assembly process. Every single weld point in a traditional car frame represents a potential failure zone where vibrations can start and where noise can enter the cabin and where structural integrity can be lost during a high-impact collision. This is where the E0X platform enters the stage as a clean sheet design, which means it was conceived with a purely electric mindset from the very beginning, without carrying over any of the baggage of the internal combustion era. The revolution starts with a process known as integrated die casting, which completely abandons the old method of joining 70 or 80 small steel pieces to form the rear underbody of the car. Instead of this complex and weak assembly, the E0X platform utilizes aerospace-grade aluminum alloys, which are melted and poured into massive precision molds under thousands of tons of pressure to create a single seamless solid unit. This leap in manufacturing technology borrowed from the world of aircraft construction eliminates the weak joints that have limited vehicle strength for 100 years and replaces them with a rigid structure that offers a level of torsional stiffness previously found only in million-dollar carbon fiber hypercars. We are talking about a chassis with a torsional rigidity of approximately 40,000 Newton meters per degree, which is a technical way of saying that the car simply does not bend or twist even under extreme pressure or when hitting a deep pothole at high speed. This structural perfection translates directly into a driving experience characterized by incredible stability and a silence inside the cabin that feels almost supernatural because there are no tiny joints to rattle or vibrate against one another. Furthermore, this new structural philosophy significantly enhances safety because in the event of a side impact or a rollover, the energy of the collision is distributed across the entire solid cast unit rather than being concentrated on a single weak weld point that could snap under pressure. This is the difference between a chain made of many small links and a solid bar of reinforced metal. By reducing the number of parts, Chery has also made the manufacturing process faster and more consistent, which means that every single car that rolls off the assembly line has the exact same structural perfection as the prototype. This isn't just a minor improvement in how cars are made, but a total reinvention of the industrial process that moves us away from the limitations of the 19th century assembly line and into a future where vehicles are lighter, stronger, and more efficient than ever before. This structural foundation is then paired with the 800-volt architecture, which represents another massive leap over the 400-volt systems used by the majority of electric vehicles on the road today. By doubling the voltage, the E0X platform can deliver the same amount of power with significantly less current, which drastically reduces the amount of heat generated by the electrical system. In the world of physics, heat is the enemy of efficiency, and by using silicon carbide power electronics instead of traditional silicon components, Chery has managed to reduce thermal energy loss by 50%. This means that more of the energy stored in the battery actually goes toward driving the wheels rather than being wasted as heat that must then be cooled by heavy and complex thermal management systems. The real-world impact of this 800-volt shift is most apparent when you pull up to a charging station because the system can handle a massive flow of energy without overheating, allowing the driver to add up to 150 kilometers of range in just 5 minutes of charging. Imagine a scenario where you stop for a quick cup of coffee or a stretch of the legs, and by the time you are ready to get back behind the wheel, the car has already gained enough energy to carry you for another hour and a half of high-speed driving. This effectively kills the primary fear that has prevented millions of people from making the switch to electric power, which is the dread of being tethered to a charging cable for hours on end during a long journey. The E0X platform is not just a car frame, but a declaration that the era of compromise is over and that the technological gap between the old world of legacy brands and the new world of high-tech integrated platforms is becoming a vast canyon that many traditional companies may never be able to cross. This is the foundation upon which the future is being built, and it is only the beginning of a much larger story that involves the brain of the vehicle and the revolutionary chemistry of the battery cells, which we will explore in the next sections of this journey into the heart of the new electric empire. The true crisis of the modern electric vehicle industry does not lie in the design of the doors or the size of the touchscreens, but rather in the invisible chemical prison known as the lithium-ion battery, which has held the entire world of transportation hostage for more than 15 years, because while these liquid-based cells allowed for the first generation of EVs to exist, they also brought with them a series of inherent risks that no amount of software could ever truly eliminate. This is where the real story of the Chery revolution begins to separate itself from the rest of the pack, because while Tesla and BYD were busy perfecting the management of liquid batteries, Chery's engineers were working to destroy the liquid system altogether in favor of the Kunpeng solid-state technology. To understand why this is a generational breakthrough, you have to visualize the inside of a standard battery, where a liquid electrolyte acts as the medium for energy transfer, but this liquid is also the source of catastrophic heat leakage and a phenomenon known as dendrites, which are tiny metallic spikes that grow during every charge cycle. In a traditional battery, these dendrites can eventually puncture the internal separators, causing a short circuit that leads to thermal runaway, which is a polite engineering term for a fire that is almost impossible to extinguish because it generates its own oxygen as it burns. This battery prison has forced manufacturers to spend billions on heavy cooling systems and reinforced armor plating just to keep the liquid safe, but Chery has taken a different path by replacing that volatile liquid with a solid ceramic or polymer-based electrolyte that is inherently stable and physically incapable of leaking or catching fire in the same way. The energy density of these Kunpeng cells is a statistic that should make every other car manufacturer in the world stop and rethink their entire business model, because we are talking about a density of approximately 600 watt-hours per kilogram, which is nearly triple the capacity of the current industry standards like Tesla's 4680 cells or the BYD Blade battery. In practical everyday terms, this means that a single charge can now propel a vehicle for up to 1,500 kilometers, which effectively transforms the electric car from a city commuter into a transcontinental traveler that can cross entire countries without ever needing to see a charging plug. This isn't just a minor improvement or a slightly better range, but a fundamental shift in the very thinking of energy storage, where the goal is no longer to manage a dangerous liquid, but to utilize a stable solid structure that offers more power in less space, with zero risk of the self-oxidizing fires that have haunted the EV industry's reputation for a decade. The confidence that this technology provides to the driver is immense because for the first time in history, a battery has been subjected to real-world trauma tests, including being shot with high-velocity projectiles and punctured with massive steel nails, only to reveal that there was no smoke, no fire, and no explosion, because the solid electrolyte remains controlled even when the physical structure of the cell is completely destroyed. Beyond the chemistry of the battery, the E0X platform introduces what can only be described as the gigabit brain, which addresses the massive communication gap that exists in almost every legacy car brand on the market today, where ancient systems like the CAN bus are still being used to handle the vast amounts of data generated by modern sensors. While these old systems were perfect for the needs of the 1980s, they are now the primary bottleneck for the software-driven future, because their data transfer speeds are like trying to stream high-definition video over a dial-up internet connection, which results in slow screen responses and limited capabilities for autonomous driving. Chery's EA 5.0 architecture replaces this outdated framework with a gigabit Ethernet system that offers data speeds up to 1,000 times faster than traditional cars, effectively turning the vehicle into a high-performance computer on wheels that can process and react to road hazards in a fraction of a second. This faster data flow is supported by dual NVIDIA Orin X chips, providing a processing power of 58 teraoperations per second, which means the car is constantly reading the world around it, with a level of detail and speed that far exceeds human perception, allowing the system to detect a child running into the street and apply the brakes before the driver's brain has even registered the danger. This digital intelligence is then funneled into the flying fish chassis, which is a predictive suspension system that doesn't just react to the road, but actually reads the surface ahead, using advanced LiDAR sensors to scan for potholes and speed breakers before the tires ever touch them. In a standard luxury car, the suspension is reactive, meaning it feels the bump and then tries to compensate for it. But the flying fish system is proactive, meaning it adjusts the dual-chamber air suspension and continuous damping control in advance to create what is often called a magic carpet effect, where the occupants feel as if they are floating above the pavement rather than driving on it. This system is further enhanced by active rear-wheel steering, which makes a massive 5-meter sedan feel as nimble as a small hatchback in tight city corners, while providing incredible stability during high-speed lane changes on the highway. This integration of aerospace-grade materials, solid-state chemistry, and high-speed digital architecture represents a total convergence of technology that moves the car beyond being a mere mechanical machine and into the realm of an intelligent, responsive partner that protects its passengers through superior engineering rather than just thicker steel. As we move toward the final section of this transformation, we must recognize that the old automotive hierarchy is being dismantled by this combination of innovations, because the real difference between a leader and a follower is no longer the name on the factory wall, but the platform beneath the seats. The E0X revolution is a warning to the world that technological leadership is no longer a birthright of the West or the established giants of Japan, but is now being claimed by those who are willing to reinvent the entire mindset of manufacturing and energy storage from the ground up. This is not just a story about a new car, but about the end of the battery prison and the beginning of a future where transportation is lighter, safer, faster, and more intelligent than anything we have ever imagined possible. And in the final part of our journey, we will look at how this all comes together to shake the very foundations of the global car industry and what it means for the millions of drivers who are waiting for a reason to finally believe in the electric dream. The true culmination of the E0X revolution is not found merely in the cold chemistry of the battery or the rigid aluminum of the frame, but in the invisible layer of intelligence that connects the road to the passenger's soul through the flying fish chassis system, which represents a departure from over a century of reactive automotive engineering. Because for the last 100 years, suspension systems have been essentially passive devices that wait for a bump or a pothole to occur before they attempt to dampen the shock, but the E0X platform operates on a predictive level using advanced LiDAR-based surface scanning technology that reads the topography of the road hundreds of times per second before the tires ever make contact with an imperfection. This allows the continuous damping control system and the dual-chamber air suspension to prepare for the impact by instantly softening or stiffening the ride in a way that creates a magic carpet effect where the car doesn't seem to be rolling on the asphalt, but rather floating slightly above it, as if gravity itself had been partially neutralized by the sheer speed of the digital processing. This level of control is further enhanced by active rear-wheel steering, which effectively shrinks the car's physical footprint during tight city maneuvers by rotating the rear wheels in the opposite direction to the front ones, while at high speeds on the highway it rotates them in the same direction to provide a level of lane change stability that was previously the exclusive domain of professional race cars or million-dollar exotic machines. This mechanical ballet is orchestrated by the dual NVIDIA Orin X chips, which serve as the central nervous system of the entire vehicle, providing 58 teraoperations of raw processing power every single second to ensure that the car is not just a moving machine, but a sentient partner that can recognize a pedestrian or a sudden obstacle and react with a level of precision and speed that far exceeds human reflexes. This transition from a mechanical vehicle to a software-defined platform is what truly creates the brain gap between the new Chinese innovators and the legacy brands of the West, because while companies like Mercedes or Ford are still struggling to integrate old electrical architectures with new software needs, Chery has built a gigabit Ethernet-based system from the ground up that allows for seamless over-the-air updates and a service-oriented architecture that means your car can literally become smarter and more capable while it is parked in your driveway overnight. We are witnessing the absolute destruction of the traditional automotive hierarchy, where the size of the logo on the hood used to be the primary indicator of technological leadership. But in this new era, the real power is determined by the speed of the data transfer and the stability of the solid-state chemistry and the efficiency of the integrated die-casting process, which means that the historical prestige of the old giants is rapidly becoming irrelevant in the face of this overwhelming technological onslaught. As we reach the final conclusion of this journey, it is important to realize that the shift we are seeing is not just a new model launch, but a total category change that forces us to rethink what a car actually is, because when you combine the E0XS structural rigidity with the Kunpeng battery's 1,500-kilometer range and the gigabit brain's lightning-fast reactions, you are no longer looking at a traditional electric vehicle, but at a new species of mobile technology that has escaped the battery prison and the structural limitations of the past. The shockwaves from this transformation will be felt in every boardroom from Detroit to Stuttgart as the realization sets in that the technological lead has shifted to those who were willing to take the clean sheet approach and reinvent the wheel rather than just electrifying an old-world design. If you want to remain at the absolute forefront of this rapidly evolving landscape and be the first to understand the deep technical shifts that are making today's best cars look like ancient history, then you must subscribe to this channel and turn on all notifications, because the world of mobility is changing faster than ever before, and the next big revelation is just around the corner. waiting to challenge everything you think you know about the future of transportation. This has been a deep dive into the E0X revolution and the end of the old automotive order, and we will see you in the next exploration of the technology that is rewriting our world one breakthrough at a time.